Okay, so this is going to be my attempt at talking about asynchronicity in the event loop. Point of fact, it's pretty complicated. Um, I will share to the extent that I can. Oh, you know what? I think I've been, did I? All right. Well, anyway, if we get complaints that this is not the channel that I actually advertise this on in Slack, I'll change it. But at this point, I don't think anybody's attending remotely. I think this is mostly just for recording. Okay, so asynchronicity and the event loop. What is asynchronicity? Can somebody define for me?
Things happening parallel.
I'm glad that you said that. The answer was when things are happening in parallel, because that's actually not what asynchronicity is. JavaScript is single-threaded, which means nothing is happening in parallel. There's only one thread. But I can see why you would think that.
Yeah.
It's when you're talking on Slack and somebody's taking a while to respond, so you've got to do something else.
Ah, a real world non-JavaScript example. I love it. Yes. So you are talking on Slack, but the person you're talking to has like dropped off. They're taking a while to respond. So you're like, okay, until that person responds, I am going to work on my Express application. And then when you get pinged that the person responds, and in order for me to make this a little bit more perfect, you finish your Express application, and then you're like, oh, I have something in Slack, and you go back to Slack. So yes, working on stuff while you're waiting for other stuff. So it sort of feels like working in parallel, but the fact is you're not actually doing any work on Slack while you're working on Node. You're just waiting. Yeah. Okay. Did you just think of that now?
Yeah.
That's a great analogy. All right. All right, so in this lecture, I'm going to talk about the call stack. And so just to continue with Kelsey's analogy, of which I am so enamored, the call stack would be, okay, first I'm working on Slack. So Slack is part of the call stack. And then when you're like waiting for somebody, Slack is not part of the call stack. And now your call stack is working on your Node app. And then when you finish your Node app, you're done with everything in the call stack, then you check to see if there's anything on Slack to respond to. So I'm going to talk a little bit more about the call stack because it has applications outside the event loop, but that's basically what it is. Callbacks and promises. Those are those notifications from Slack that somebody has responded. The event loop, that is how JavaScript manages both working on the call stack and working on any callbacks and promises that might have follow-up work that needs to be done. And then meddling with the event loop. So this is where you can actually, like, instead of using promises and promises and callbacks, you can actually use these things called set timeout and process.nextTick to insert whatever, stuff that you want to happen at certain points in the event loop. And then I just want to finish up with sort of a brief how the browser and Node work a little differently. That's one interesting thing about JavaScript is you never really know what engine you're going to have interpreting it, right? If it's running in the browser, it's going to have whatever that browser's engine is. If it's running on Node, it's going to be based on the Chrome V8 engine, but it's still going to be a little bit different. So just some clarification about browser versus Node. Okay, so I want to talk about, this is part of the MDN documents say an API should always be asynchronous even where it doesn't have to be. What do they mean by an API here?
URL to another website? Maybe?
Yeah, so we've talked about this a little bit before here, but I think maybe before your time, Kelsey. So API, there are actually three sort of categories of API. So one is the one that you're thinking of, where it's an interface to a third-party database, functions, etc. Right? This is where you log in via Facebook for your app, or your app is capable of making a tweet on behalf of somebody else, or your app doesn't use its own data, but instead goes to a third-party site to get the data for weather or something, right? That's so let's. So I'm going to call this one a RESTful API. And so this one, is, yeah, so this is a RESTful API where you make a web call through curl or through requests, or HTTP request or whatever you call it in Node, right? But you basically make a web call. All right, so another type of API, which is also a third-party database, let's see, via HTTP. Another one is a web API, which is front end. So this one, you would, for this web API, you would include a script in your HTML, which would give you functions and objects and other things that you can use in your front end. So like Google Maps is a good example of this. And then there's more of a programming API. And this is an interface to functions, classes, etc., through a programming language. So JavaScript has an array API, how you can interact with arrays. It has an object API, how you interact with objects. Modules have APIs. The Express module has an API, the tools that you get when you require Express. Chai has an API. These are all programming APIs. By the way, this is RESTful is official, web is semi-official, and programming is just I made up out of my head. Okay, just so you know. But this is the way I think of them. Are there questions on this?
So for the definition we were just talking about,
Yeah.
the node design philosophy, that's talking about the third.
The node design property is talking about the third one. If you make a new module for Node, it should be asynchronous. And, or if you make, so part of its design philosophy is an API should be asynchronous even where it doesn't have to be. So why?
Just unintended consequences. Just covering your butt.
Covering your butt? Okay, unintended consequences. What might those unintended consequences be?
Just that's the thing that you're calling isn't responding for some reason.
Ah, okay. That's so the thing that that's responding isn't calling, or isn't the thing you're calling isn't responding for some reason. Okay, so Python is totally synchronous. Python has like the opposite philosophy. Does that make Python a bad language? Hint: never say Python is a bad language in my presence.
No, but just because Python is a bit faster than JavaScript and it can handle the API calls synchronously.
It's not that Python is faster, but it's good to think about what are the differences between Python and JavaScript. It does have to do with blocking. Why is blocking more important for JavaScript than it is for Python? Python is multi-threaded. You're absolutely right, but it does take some work to get different threads doing different things on Python. But that's totally true. That JavaScript is single-threaded and Python is multi-threaded. But it's even more basic than that. Yeah. So what do you think in there, Celeste, about how they're used?
Well, so like the blocking behavior in JavaScript, if you have a web page and someone clicks on it, you don't want to block everything else that's happening while you do this one thing.
Yes. On the back end, blocking is not that big a deal. On the front end, blocking is huge, right? If you say, okay, I'm going to make an AJAX call to go back to the server and get some data. And while I'm doing that, you are not allowed to click on anything on the page and get a response. Or I'm just going to save up all of your clicks, and then later I'll give it to you all in one bunch after I've gotten the data back, right? You want the page to remain responsive while something time-consuming, often going and getting data, is taking place. Yeah. So JavaScript is non-blocking. It's this asynchronous because, so like Kelsey was saying, it follows a single thread. And you don't want to make the thread wait. You want to register a callback and just let the thread continue. And again, this is especially important in browser JavaScript. You do not want the page to be disabled while you're waiting for your friend on Slack to get back to you. All right, questions on this? I'll make these slides available, Celeste. But I know I listen better when I write. Okay, so let's talk about the pieces of the event loop. So the first thing I want to talk about is the call stack. Brittany has a pink box, which always means deliciousness within. All right, and I want to do this call stack example. So here I have 3 functions. My first function is get tax by state. Takes a state, and apparently your only 2 possible states are California and New Hampshire, but clearly if this was a real function, it would give you all the states. So if it's California, 8.5% sales tax. If it's New Hampshire, 0. Then I have this function called calculate tax, which takes a total and a state. And basically it just takes whatever percentage is returned by get tax by state and multiplies it by the total. Then I have a calculate total, which takes an array of prices. It sums up the prices using reduce, and then it returns whatever calculate tax returns. But actually it should, because this is just the tax, it should actually also add the total. I'll fix that in a minute. In fact, I think I'll fix that right now. Right, you want, this just returns the tax, so you want to add the total onto the tax. So if I run, all right, so while I'm here, I'm going to just copy all of this. So the key here is that I have one, if I run calculate total, it's going to call calculate tax. Before calculate total is done, right? It can't finish calculate total until it's done calculate tax. And then if I run calculate tax, it has to call get tax by state. When I run get tax by state, then get tax by state returns. But when I call get tax by state, there are 3 functions open. This function is open, this function is open, and this function is open. Then get tax by state finishes. Now I have only 2 functions open. Then calculate tax finishes. I have only this function open. This function finishes, and now I have no functions open. And that's the call stack. So let's, there's this really cool tool called Python Tutor, but you can use it in JavaScript that helps you visualize this call stack. So I am going to go to Python Tutor. Let's see. Can I? No. All right. I can't copy and paste because I already. Okay. Let's just do this. Nope. Okay. Python Tutor, and I'm just going to click JavaScript, but clearly I first used this in Python. Ooh, get live help. That's fun. So I'm pasting all of this in. And let me also paste in my my call here. Okay. All right, cool. So now I am going to visualize the execution. Okay, and so what I'm going to do, can you guys still read that okay? Okay. So here it's giving me my frames and my objects. And I'm just going to step through. So the first thing it does is define get tax by state. So in my global frame, I have something called get tax by state. Then it defines calculate tax. Then it defines calculate total. Fine. Okay. And now it's going to start running this calculate total on these prices. So when I do that, the first thing it does is it says when I do that, price array is now set to this array here. And on let's see, and total is undefined. But on my call stack now, I have this calculate total. My call stack right now is this one function. Now, why did I get another function on my call stack? This isn't one that I talked about when I was giving you the 3 thing. What function is this one?
Taking it from in the calculate total, it's a user base price array is reduced and it has 2 parameters.
It is this exactly. This is the anonymous function right here. Right? So right now I actually have 2 functions on my call stack. Calculate total and my anonymous function. Okay, my anonymous function returned 4.87. Ah, my anonymous function is running again. So it didn't add another, like, it finished that total, or it finished that function before it added another one onto my call stack. So now I'm doing another one. Okay, now I'm running that function for a third time, and it returns, and now I'm back into my calculate total, back to having one function on my call stack. Okay, so now I have this one function on my call stack. This is still my array. Now I have a total of 21.02. Now when I run this line, what's going to happen to the call stack? It's going to add calculate tax to the call stack. Okay, so now I have two functions in my call stack. Calculate tax has its own local variables. Now I have three functions in my call stack. And it's a stack. What's the difference between a stack and a queue?
Stack is the last in, first out, and the queue is first in, first out.
Stack is last in, first out. A queue is first in, first out. Here's a secret. It drives me crazy in meetings when they say, let's create a stack, because they're not creating a stack. They're creating a queue. First in, first out.
But that has attention.
I actually have. I've been thinking about it, but every time it happens, like when there's a stack, it means there's a lot of energy in the room, like for question asking, and I don't want to interrupt that with like a pedantic lesson on what stacks and queues are. So, yeah. So anyway, so this is a stack because the last one in, this last function, is going to be the first one closed. Okay, so okay, yes. So now that one finishes. It returns 0.085, and now in my call stack, and this is floating point math, which is a whole other topic, but that's the reason we get this like tiny little remainder over here. Floating point math, look it up. It's fun. And so now we have two items in our call stack. Then that one finishes. We have one item in our call stack. And now we're done. And this is what was returned. And our call stack is totally finished. Okay. Questions on that? By the way, if and when you ever get around to playing with recursion, this is an amazing tool to realize what's going on in recursion. It's a pretty good tool just in general if you want to know exactly what your code is doing. Okay, but back to the main topic of our lecture. So I needed to tell you about the call stack because it is part of the event loop. It's also a really good thing to know about. I want to talk about other things that you hear about with respect to the call stack. One is a stack trace. Stack trace tells you what functions were running when your code broke. You guys have seen stack traces, unless your code has never broken, which I doubt is the case. Tells you where in the call stack your error occurred. And I think I have, in earlier times, expressed frustration with Node's stack traces because they don't tell you where in your code it's going on. And as I was researching this lecture, I learned that Node stack traces are truncated to 10 lines. You only get, and so if your call stack is more than 10 functions deep, which it often is if you're using things like Express, then it's not going to tell you which function in your code caused it. But there are ways around that. There are things that you can do. There are settings or modules that you can use, which I am pretty committed to using now because I have found Node stack traces to be pretty useless because they don't tell me where in my code the problem is. I don't care where in Express the problem is. I want to know where in my code the problem is. Okay. Stack Overflow. Have you heard of Stack Overflow? Yes. Stack Overflow is when the call stack exceeds its allotted size. And then the community forum that is Stack Overflow just took its name from that. It's usually because you did a bad job of recursion. That's usually the reason. But there's a link to more on Stack Overflow if you want to hear more about it. Okay, so that's the call stack. Let's talk about callbacks and promises. I'm going to talk about this briefly because you guys, have been working with it a lot. But basically, it's a way to do some time-consuming work without blocking. And you specify what to do when the work completes. This work is stuff that either the web API is going to do. It's basically stuff that the JavaScript engine is going to do and your code is not going to do. So it's things like looking at databases, getting things via Ajax, getting data from another website, reading a file, right? These are things that your code is not doing, but sort of the underpinnings of JavaScript is doing. But how does it know when to run this after complete code? So now we're not talking about how to use promises anymore. We're talking about under the hood, how promises actually work. Finally, the event loop. Full confession, the first time I had heard the event loop was a few days after I started working here, right? This is not a concept that we have in Python yet. Python is starting to incorporate it more. They're incorporating an async and await type thing. Okay, and so I just want to warn you that I'm going to be doing some simplification here because we only have an hour for this talk. So I'm not going to talk about tasks versus microtasks. Like the task might be wait for your friend to get back to you on Slack, or after your friend gets back to you on Slack, you're going to type a message, right? And there might be a micro task involved in like how you're going to type that message and so forth. I have links at the end of this if you're really interested in the nitty gritty. And then event loop. The event loop has a lot of phases. I'm really only going to talk about 2 of them. There are other phases that again, I have a link at the end that talks in more detail about the phases. All right, so I want to talk about the concept of the event loop in words. While there is still stuff to do, right? While the program is still running, basically while the program is still running. First, you run through the call stack. So you've got a function, you do everything you need to complete that function and have the call stack be empty. Once the call stack is empty, then you run through your message queue. It's also sometimes called the task queue. That is the queue that is storing up the things that needed to be done after work was done. That's storing up your callbacks from callbacks and promises. That's your to-dos, which only come back asynchronously. You're done with the message queue, go back and run the next function that your program is supposed to run. You're done with that functions call stack, go back to the message queue or the task queue and see whether there's anything there. You're done with the task queue, go back to your program, right? And you keep doing that. That's the loop. Okay, so here are two images that I liked for the loop. Here's the event loop as a ninja or something. So here's the synchronous tasks building up in this call stack. This is as soon as the stack is empty, I will move tasks from the queue to the stack. And I'll do that one at a time. Okay, and here's another one. While there's code to execute the callbacks, exit the process. Do you have more code to execute? Well, while there's code to execute the callbacks, exit the process. Do you have more code to execute? And so forth. You guys have questions on this? Yeah.
How does it know when the call stack is ready to insert?
Yeah, the question is, how does it know when the call stack is ready to insert? It's when you don't have any running functions, right? So basically, if we went, so here, right? If I'm running this line, it is going to complete this function and any functions that this function calls, and then the call stack is empty. So then the loop is going to go and it's going to check to see if there's anything in the message or task queue.
So basically after each single function?
Well, but not after this one, right? Because this one didn't clear the call stack.
Oh, right.
Yeah.
Callbacks in that.
Well, it's not callbacks, but it's after there is nothing on the call stack. And if your single function didn't call any other functions, then yes, it's after that function completes. But if it called other functions, you have to make sure, just because this one has completed, you're still in the middle of a call stack, so it's not going to look to the message or task queue.
But does that, just to be clear, does each function that line 12 is calling, it has its own little call stack?
No, only the program has a call stack. Just one call stack. Other questions? Okay. So another thing, so when I was doing research on this, all right, so this talk, if you're interested in more on the event loop, I highly recommend this talk. It's linked to at the end. But this guy made something that has this call stack. It has those web APIs. That's the thing that I was talking about, which is different from the web API thing that I talked about earlier when I was classifying APIs. So sorry, this is more of the programming API for the JavaScript interpreter on the web. But basically, so you have the call stack, you have stuff that you're waiting for, which is the web APIs, and then you have the callback queue, and this is the loop going back and forth. So the web APIs, if this were Node, it would be things like going to get stuff from the database. Here's just a set timeout. So the set timeout is part of the web APIs, and so the set timeout is what's actually going to that's the thing that we're actually going to be waiting for. So let's take a look at this code. I'm going to take a look at it in Atom. Okay, so $on. Okay. We're just going to say, just forget about the dollar for now. We're just, there's an on click that says when you click on the button, and the button being, let's see, so this, I think here, this is our HTML. So you can totally edit this and play around with this yourself, and I completely encourage you to. So this is, the HTML just has a button. When the button is clicked, after 2 seconds, because it's 2000 milliseconds, it's going to console log you clicked the button. Then it's going to console, so it does this, it console logs hi, that's just when you start it, that's going to be the first thing that happens, because this is just setting up an event listener. And then it's going to wait 5 seconds and console log click the button. And then it's going to console log welcome to loop. So we're going to see hi, welcome to loop, and the next thing we see might be click the button. But if we decide to click the button in the meantime, we actually might see you clicked the button first. Okay, and we're going to see how all of that plays out here. So let's just not click the button, and let's just look and see. So if I save and run, console logged hi, it's waiting for this, this web API is waiting for the button. It did a timeout, that went to the callback queue, and then it console logged click the button. And it doesn't look like it's actually tracking that anywhere. Now this event listener is just hanging out here. I'm gonna, just so you can see it a little better. This event listener is just hanging out, and when I click this, then it does that on click, then it did the set timeout, then it did it says set timeout here, then the set timeout was done, and then, I don't know what it clicks. You click, you click the button. So again, click the button, we got the on click, and then we got the timer, and then it console logs you clicked the button. Oh, I guess I could have had the console log here. So all of this is like, just doing all this console log. It'll be easier on your screen when you don't have to have the font so big. Highly encourage you to play around with this. And I, as the slide writer, claim that that one is fun, but you may beg to differ. Okay, so let's talk about process next tick and set immediate. This is sort of messing with the event loop a little bit. Set immediate adds to the end of the message queue. Again, also sometimes called the task queue. So it's basically, when you say set immediate, you say wait until the call stack is empty, and then once the call stack is empty, then go through the items in the message queue, and this is going to be the last of them. So you're saying, I don't want to interrupt anything here, but put this at the end of the message queue. That's what set immediate does. So it waits until the next loop when it gets to that message queue. It adds a process.
To the current message queue, that something could be added after set immediate.
Yeah, something could be added after set immediate. But set immediate is going to make way. It's going to give precedence to anything that's already in the message queue. Process.next tick cuts the line. It adds to the beginning of the message queue. Sometimes that's necessary in recursion cases where you've got a bunch of things and it just is continually adding to the end of the message queue. And so if you add to the end of the message queue, it's basically never going to get to it, or at least not in the time that you want it to. Ah, you are anticipating browser versus Node. It's mostly the same. There's some differences under the hood. Like, for example, just the Chrome browser. I didn't do any research on other browsers, but just the Chrome browser uses live event to implement its event queue or its event loop. Whereas Node, I've never heard this pronounced, but I'm guessing it's libuv, but I don't, libuv? Okay. So whereas Node uses libuv, so just some under the hood differences. And then browsers, you can use set immediate or next tick. I'm not even sure you can use next tick, but they are not supported. They are not reliable. All right, and then those resources that I was talking about, how this is not complete. It simplifies stuff. Here's the Philip Roberts video, which is really good. If you want more on the event loop, I highly recommend it. A nice explanation, including some more detail on web workers and those micro tasks. Web workers are actually also just like little, like, you say you like event loops, here's an event loop within your event loop, basically. And more detail on those phases. Like that sort of, there are actually 5 phases to the event loop, and I'm really only talking about a couple of them. The others are more obscure and, you know, sort of more with internal stuff. But again, if you like this stuff and you want to learn about it in more detail, here's some reading for you. All right, and that's what I have. It looks like this took only 45 minutes. How do you feel like your understanding of the event loop is now?
I first heard about it like maybe months ago.
Uh-huh.
And I watched that video and I didn't understand anything.
Yeah.
And then I think in the beginning of phase 2, I watched it again and
Okay. So you're getting there. That's good. That's good. Yeah, you should just set like a timer on your phone to watch that video once a month and see what happens, you know? What about the rest of you? Yeah.
Maybe some more playing around with it.
Yeah, that's definitely a good idea. Playing around, yeah, and you know, reading what other people have to say about it. But yeah, I think that it's kind of fast, that loop thing, but I think it's really cool that it, you know, shows you like really what's going on there. All right. Does anybody have anything they want to discuss in our last 13 minutes? Either yes or no are both valid answers.
I just have a question.
Yeah.
But I don't know if this is the right, but I'm just starting to use Cheerio.
Good Lord. Yes.
Should I ask it some other time?
Yeah, I mean, so this is my opinion. I think Cheerio is interesting, but I don't think it's worth the amount of time that gets spent on it in phase 2. I would take that time and I would instead use a third-party API. I would instead use a RESTful API rather than HTML parsing. That's my my 2 cents. Why?
Yeah.
Because as a web programmer, you will use RESTful APIs. As a person who likes monkeying with the web, you may use HTML parsing. It's not that common in professional web programming.
Not even illegal sometimes. Right?
Sometimes it is not even legal to scrape websites and parse them. Yeah, so basically this is our way of getting rid of learners that we don't want anymore. We just we just have them do the Cheerio exercise, and then we have people come and take them away. Yeah.
So if I do want to do like scrape a web page, are there other ways to do it besides Cheerio?
Yeah, there's Python and Beautiful Soup, which makes a whole lot more sense. That's a good question. I don't know.
Yeah. But what does Google do? You know?
Google is not a node shop. Google would probably use Python. But more likely they probably use, I don't know, they might use Java. That's a good question. Let's see if there's any. What's that? Yeah, exactly. Let's see what tools. To acquire data without coding. Okay, so let's see. What? I don't know. Can you guys think of a better question to ask? Because like nobody's telling me what Google actually does. You know, there's like, here's this like web scraper Chrome extension, but that's, I mean, that's not what Google does behind the scenes, right? So what tools do Google? Yeah, I was just thinking the same thing. You and me, man. It's like mind meld. I still owe you a beer, by the way. Don't let me forget it. Exactly, because of the freaking Cheerio. All right. There is no known case or broken law. Google does not take legal action against scraping. Google uses a range that makes scraping, but I don't want to scrape their results. This is so meta, right? Like I'm scraping the scraping results. So that's actually not what we want. Google internal.
So it's not legal.
Some.
At the bottom of the any site, there's going to be some information. You say you have to check there and they they say like on Craigslist there are some information there and some cannot.
So if you're scraping, you need to first scrape to see if the schools got scraped.
Yes, exactly. Yes, yeah. Especially if you are trying to make money from it, right? Like I think people don't care as much if you're doing like a student project. Like who cares, right? But if you're trying to make money from it, then people are going to be like, no, you cannot use our information to make money, right? Yeah. This is. I'm not this is pretty old, so I don't even know if that's good, but
It's not in.
no, yeah. So let's just see, unless people have other questions. Do people have other questions? So let's do Google Jobs. Let's look and see the Google Jobs in the search engine. Oh, that is not Google in any way, shape, or form. Okay, so let's just oops. I wanted to search jobs. This is really getting so meta. For search engine. Okay. Okay, the reason I'm doing this is I want to see what language they say you need to have to work on their search engine.
First one is possible.
Let's see.
Searching.
Participate in cutting ed. Okay, yeah, so C or C++ or Python. Because nobody in their right mind would use Node or JavaScript on the back end, but that's, you didn't hear it from me. Yeah. How's your PhD in computer science coming along?
Slowly.
Yeah, okay. That's okay. It could be machine learning. All right. Okay. Well, thank you for attending lecture, and stay tuned tomorrow for office hours.